Everyone, welcome back to another lesson in MCV4U. Today we'll be talking about evaluating limits, part two. And today specifically we'll be talking about what is called the change in variable strategy. And so it says sometimes by changing the variable of a limit, the process of dividing the common factor may be simplified, allowing for substitution. So let's take a look at this first example here. So here it says the limit as x approaches 8 of the function x minus 8 over the cube root of x minus 2. And so if we look at this, the first part of this function, so if we take a look at this cube root of x minus 2 looks like the first part of a difference of cubes. And if we remind ourselves with the difference of cubes formula, so if a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. So remember, that's a difference of cubes. And here, if we look at the sum of cubes, it's a cubed plus b cubed is equal to a plus b, a squared minus ab plus b squared. Okay, so if we start here, if we look at this, you know that if we have x be equal, x is equal currently to the cubed root of x. But if we're trying to create it so it creates that difference of cubes, this first part of the difference of cubes, then we're going to have to cube this. So if we put that cubed, and we know that 2 cubed will give us 8. So 8 is equal to 2 cubed. So here we can develop our equation for a difference of cubes. And so that would be the cubed root of x cubed minus 2 to the power 3, or 2 cubed. So if we change it, so we look at the cube root of x and we let the cube root of x equal another variable. So in this situation, we'll make it a. So let's make the cube root of x equal to a. So to get it so that it just has x by itself, we can cube root everything, or so we can cube everything. And so here, x will be equal to a to the power of 3. So here we have x is equal to a to the power of 3. And here we see that it's x, as x approaches to the value of 8. So let's sub that in. So when x is approaching 8, we see that here the cube root of x. So that means here we see that a is going to be approaching 2. So here a is equal to 2. And so now we have to rewrite this limit based on these things that we're going to substitute in. So instead of the limit as x approaches 8, we are now going to write it as the limit as a approaches 2. And so instead of x, we now have m cubed. So we have a cubed minus 8 And we see that the cubed root of x has now just become simply a, and we have a minus 2. So we see here at the top, we have difference of cubes. So with this difference of cubes, we have the limit as a approaches 2 of a minus 2 a squared plus 2a plus 4 all over a minus 2. And here we can cancel out this a minus 2. We'll simply be left with the limit as a approaches 2 of a squared plus 2a plus 4. And since now we have here a squared, since now we have a squared plus 2a plus 4, we can simply sub in this value of 2 into each of these components of a. And since we got rid of that denominator there, so got rid of the restrictions, and so now we have equals 2 squared plus 2 times 2 plus 4. So we have 4 plus 4 plus 4, so give us 12. And so just a quick note here, so whenever a variable is changed, we must also change the limit to reflect the new variable. So in this situation, we subbed in a for x, and so initially started as the limit as x approaches to 8, and then we changed it to become the limit as a approached to. Okay, so let's look at this next example here. So here we have the limit as x approaches 1 of square root x minus 1 over the cubed root of x minus 1. So do the same thing that we did in the previous question. To start, we'll let the cubed root of x equal to a. If we cube that, then we'll see that x is equal to a cubed. And here we see that the square root of x, we can rewrite that to be x to the power of 1 over 2, or x to the power of 1/2. And we know that the cubed root of x is equal to x to the power of 1 over 3. So here we want to find the lowest common exponent, similar to a lowest common denominator, but here we're looking at it in terms of exponents. And the lowest common exponent here between 2 and 3 would be 6. And so here we can let x to the power of 1 over 6 also equal to a. So x to the power of 1 over 6 also equals a. And here, if we look at this, we have x to the power of 1 over 6 is equal to a. And here, if we square that, we get x to the power of 1 over 6 squared is equal to a squared. And here we see that x to the power of 1 over 3 is equal to a squared. And so that will help us when we're trying to sub in these values here. If we do the same thing, when we cube it, so here we have x to the power of 1 over 6 is equal to a, and let's cube all of that. We get x to the power of 1 over 6 to the power of 3 is equal to a cubed, and therefore x to the power of 1 over 2 is equal to a cubed. Okay, so based on all of that, now we can sub in this new equation here. So here we have the limit as a approaches 1. And the reason why it's still a approaches 1 is because if we look at here, the x to the power of 1 over 6 is equal to a. If we simply sub in a is equal to 1 into this equation, it will still be equal to 1. And that's because here, if we look at this, right, as a approaches 1, we sub that in. And the reason there is because 1 to the power of 1 over 6 is still equal to 1. So here we have the limit as a approaches 1 of a cubed. So remember, x to the power of 1 over 2, or square root x, is equal to a cubed. So we have a cubed minus 1 over a squared minus 1. And remember, x to the power of 1 over 3 was equal to a squared. So here we have a difference of cubes. And we have a difference of squares. So here, if we expand this, we get the limit as a approaches 1, a minus 1, a squared plus a plus 1 at the top of the numerator. And at the bottom, we get a minus 1, a plus 1. Here, we can cancel out a minus 1. I'll be left with the limit as a approaches 1 of a squared plus a plus 1 over a plus 1. Okay, so now we can sub in that value of a is equal to 1 into our equation. And so here we'll get 1 squared plus 1 plus 1 over 1 plus 1 is equal to 3 over 2. Okay, so now we'll continue into the next question here. And so the next question is the limit as x approaches 0, x plus 8 to the power of 1 over 3 minus 2 over x. And so here we will simply let x plus 8 to the power of 1 over 3 be equal to a. So usually you make the thing that seems to be the most complex equal the variable, and in this situation it'd be x plus 8 to the power of 1 over 3, and we sub that in to equal to a. Here we can see that if we cubed root both sides, then we would get x plus 8 is equal to a cubed. And there we see x is equal to a cubed minus 8. And so that's what we can sub in for the x value. Here, we again have to change our value of x approaches 0 to the a value here, or a approaches what value? So a here is equal to 0 plus 8 to the power of 1 over 3. And here we get 8 to the power of 1 over 3, which is equal to 2. So here we see that a is going to be approaching 2. And so we can rewrite this. We get the limit as a approaches 2. And here we see again that our x plus 8 to the power of 1 over 3 will be equal to a. Here we can rewrite this as a minus 2 over, and x has become a cubed minus 8. Here, so we have the limit as a approaches 2. So a minus 2 at the numerator, difference of cubes at the bottom. This gives you a minus 2, a squared plus 2a plus 4 at the numerator, the denominator. Let me just expand this. Change this here. So we have a minus 2 at the top of the numerator and a minus 2 in the denominator. Cancel those out. Here we're left with the limit as a approaches 2, 1 over a squared plus 2a plus 4. And now we can simply just sub that in to our equation, or we can sub a is equal to 2 into our equation. So here we will get 1 over 2 squared plus 2 times 2 plus 4, which is equal to 1 over 12. And remember, that would be a finite limit. So finally, let's look at this last example here. And it says determine the values of a and b so that the limits of y is equal to f of x exist at x is equal to -3 and x is equal to 2. Then sketch the function. So here we have ax plus 6, and that's when x is less than -3. And we have bx squared when it's between when x is between -3 and 2. And we have x plus 10 when x is greater than 2. Okay, so let's look at here. Again, x is less than 3, which means that our left-hand limit is as x approaches 3 negative. Here at -3, we have a right-hand limit as x approaches -3. From the right, we have another left-hand limit as x approaches 2 from the left. And here, the last one here as well, we have a right-hand limit as x approaches 2 from the right. Okay, so here, remember, in our criteria for how these exist, so again, our limit at x approaches -3 exists if this criteria is met. If the limit as x approaches 3 from the left of this function f of x is equal to the limit as x approaches 3 from the right of f of x is the same. And also, if our limit as x approaches 2 exist if, sorry, here there's an f of x. This one is f of x as well. So again, this exists if the limit of x as approaches 2 from the left of f of x is equal to the limit as x approaches 2 from the right of f of x is the same. So remember, that's the criteria that we need to do. And so what we're going to do here is we're going to translate limit equations into solving equations. And so here, we'll write the limit. And so the limit as x approaches 3 from the left, that formula is given to us as ax plus 6 is equal to the limit as x approaches 3 from the right. And that formula is bx squared. So here, if we sub in x is 3 and x is 3 on both sides of the equation, here we will have a -3 plus 6. So this should be -3. Let me adjust this. Sorry, these should be -3 here. So here, if we sub in -3, we'll get a times -3 plus 6 is equal to b times -3 squared. So here we'll have -3a plus 6 is equal to 9b. And here we can divide everything by 3, by -3. So our first equation here will be a minus 2 is equal to -3b. So that's our first equation, and we're going to have to develop a system of equations. And so our second value here is, again, limit as x approaches 2 from the left. That's from our function bx squared. That's equal to the limit as x approaches 2 from the right. That function is x plus 10. And so we do the same thing we did in that last question here. We simply sub the values of x in. So here we have b. So here we have b2 squared is equal to 2 plus 10. So we have 4b is equal to 12. B is equal to 3. So here, that's our equation. B is equal to 3, or that's our second equation we have. And simply sub b is equal to 3 into the first equation. So just write this over here. Sub 2 into 1. So here we'll have a minus 2 is equal to -3 times 3, or a minus 2 is equal to -9, and a is equal to -7. So we have a is equal to -7, and b is equal to 3. So if we put that back into our piecewise notation, we have f of x negative 7x plus 6. X is less than negative 3. 3x squared. X is between negative 3 and 2. And x plus 10 when x is greater than 2. Okay, so we can simply sub this into the equation. And so let's graph this here quickly. And just general graph here. Go -1, -2, -3, 1, 2, and 3. And for the positive values, we'll have one at 12, of one at 27, and 34. So again, just a rough general graph that's here. And so we have a couple points. So again, if when it's less than -3, you sub in -3 into that equation, you'll get a value of 27. It'll be right here. And that'll be a linear line that extends up. And then here we have kind of a parabola with our 3x squared. That goes to 0, 0. And if we sub in the value of 2 here, it'll be at 12. So stop right here at 2 and 12. And then we have x plus 10. So then it'll continue with a line this way. And so that's what our function or graphing looks like for the function f of x of -7x plus 6 when x is less than -3, and 3x squared when x is greater or equal to -3 or less than or equal to 2, and for x plus 10 when x is greater than 2.